Objectives. At the end of the course, the user will be able to know about normalization in database management system, that is DBMS, understand the concept of normal forms, understand the concept of Boy's code normal form, know about the higher normal forms. Introduction to normalization. Normalization is the process of organizing the data, that is files and tables in the database, so that it has two basic requirements. They are: there is no redundancy of data. Redundancy means storing the same data in one table. Occurrence of data dependencies makes sense. That is, data dependence means storing related data in a table. Normalization. Database normalization. Organizing the attributes of tables in a relation database to minimize redundancy. Normalization usually involves dividing large tables into smaller and less redundant tables and defining relationships between them. Example: A, B, C. Overview. Developed by E.F. Code in 1972. Redundancy is greatly reduced if tables are at least in third normal form. Normalized tables are more predictable and less costly to enter data and maintain integrity. Anomalies. If redundant or poorly formed tables are used in a database system, the three anomalies may occur. Insert. When you insert the same data in multiple areas. Update. When you have updated same information in multiple areas. Delete. When you are forming a deletion, unintended data is lost. Isolate data so changes cascade through the rest of the database via the defined relationships. Eliminate data redundancy. Improve performance. Query optimization, an attempt to determine the most efficient way to execute a given query. Faster updates due to less number of columns in one table. Index improvement. Normal forms. There are few rules for normalization. Each rule is called normal forms. Normal form. There are different types of normal forms available in the database. First normal form, second normal form, third normal form, Boy's code normal form, fourth normal form, fifth normal form. The three main types of normal forms are defined below. First normal form, that is 1NF. Second normal form, that is 2NF. Third normal form, that is 3NF. The following NFs exist but are rarely used. Boy's code normal form, fourth normal form, that is 4NF, fifth normal form, that is 5NF. Types of normal forms. First normal form, vocab, primary key, non-key attributes, determinant, dependent. First normal form, normalized. Requirements: identify a unique primary key, have just one set of values per column, have just one value per cell, eliminate repeating data. Normalization. Hints: in almost all cases, when a table is normalized, it is broken into more than one table. It is very important to identify the relationships between the parent and child tables. First normal form, common errors, unnormalized, unnormalized, first normal form, common errors, first normal form, unnormalized, normalized. Second normal form, vocab, composite primary key made of column. Partial dependency, non-key depends on part of the primary key. E implies A, whereas C, D implies AB. Second normal form, normalized. Requirements: is in first normal form primary key. Eliminate partial primary key dependencies. Non-key columns must depend on all of the composite primary key. Second normalization. Hints: in the primary key, which is made up of a single column, it is guaranteed to be in second normal form. If a non-key column is related to just one of the columns in the composite key, it partially depends on the whole key and needs to be in a separate table. Second normal form, unnormalized. Normalized. Types of normal forms. First normal form 1NF. In first normal form, table cells must be of single values. So eliminate the repeating groups in each table. Create a separate table for each set of related data. Identify each set of related data with a primary key. Consider this product table, which is not in first NF because the column color contain multiple values, such as second and fifth row has multiple values. Primary key. To bring this table to first normal form, we can split the table into two tables with primary key as reference. Primary key. Now the first normal form is satisfied as the columns of each table, product price and product color, hold just one value. Second normal form 2NF. Tables are said to be second normal form when the table meet the criteria, that is criteria. Cell must contain single value for first normal form. All non-key attributes must depend on every part of the primary key. Non-key attributes are the attributes that are not a part of the key. For example, birth date is a non-key attribute because many people could have the same birth date, so birth date column would not be a key attribute for a person table. It would be a non-key attribute of a person table. Consider the following purchase detail table. Primary key. Non-key attribute. This table has a composite primary key, customer ID, store ID. The non-key attribute is purchase location. In this case, purchase location only depends on store ID, which is only part of the primary key. Therefore, this table does not satisfy second normal form. To bring this table to second normal form, we break the table into two tables and now we have the resultant tables such as table purchase and table store. In the table store, the column purchase location is fully dependent on the primary key of the table, which is store ID, as shown in the figure above. Third normal form 3NF. Tables are said to be third normal form when the table satisfies the criteria, that is condition for second normal form. All non-key attributes should depend on the primary key. There is no transitive functional dependency. Transitive functional dependency means table A is fully functional dependent on B and B is functionally dependent on C. In this case, C is transitively dependent on A via B. Here, A, B and C are columns. Consider the following example. Primary key. In the table, book ID determines journal ID and the journal ID determines journal type. Therefore, book ID determines journal type via journal ID, and we have a transitive functional dependency, and this structure does not satisfy third normal form. To bring this table to third normal form, split the table into two as shown in the figure above. Now, all non-key attributes are fully functional dependent only on the primary key. In table book, both journal ID and price are only dependent on book ID, and also price depends on journal ID. In table journal, journal type is only dependent on journal ID. Boy's code normal form or fourth normal form. A table is in Boy's code normal form B, C and F if it satisfies the condition of 3 and F and every determinant is a candidate key. Determinant in a database table is any attribute that the user can use to determine the values assigned to other attributes in the same row. For example, employee table has columns such as employee ID, first name, last name, and date of birth. In this case, the employee ID column determines the remaining 3 fields. A candidate key is a column or set of columns in a table that can uniquely identify any database records without referring to any other data. This can be expressed as R of A, B, C, C to A, where the relation R contains attributes A, B and C. A and B form a candidate key. C is the determinant for A. A is functionally dependent on C. C is not part of any key. Anomalies, that is duplicate data or repeated data, can also occur where a relation contains several candidate keys where the keys contain more than one attribute. They are composite keys. An attribute is common to more than one key. Consider this example. Campus table, which is not in B, C and F because no 2 buildings on any of the university campuses have the same name. Thus, room or building to campus, as the determinant is not a candidate key. This table should be decomposed into 2, a table in which table 1 contains columns such as course, class, time and room or building. Table 2 contains columns such as campus and room or building, thus satisfies B, C and F conditions. Fifth normal form. An entity is in fifth normal form 5 and F if and only if it is in the fourth normal form and every joint dependency for the entity is a consequence of its candidate keys. In this example, namely one involving agents, companies and products. If agents represent companies, companies make products and agents sell products, then we might want to keep a record of which agent sells which product for which company. This information could be kept in one record type with 3 fields. For example, although agent Smith sells cars made by Ford and trucks made by GM, he does not sell Ford trucks or GM cars. Thus, we need a combination of 3 fields to know which combinations are valid and which are not. But suppose that a certain rule was in effect. If an agent sells a certain product and he represents a company making that product, then he sells that product for that company. In this case, it turns out that we can reconstruct all the true facts from a normalized form consisting of 3 separate record types, each containing 2 fields. These 3 record types are in fifth normal form. Boys Code Normal Form. Boys Code Normal Form (BCNF) is considered as a special condition of 3NF. BCNF deals with certain types of anomaly, that is repeated data, that is not handled by 3NF. A table is in BCNF if every determinant is a candidate key. A candidate key is a column or set of columns in a table that can uniquely identify any database record without referring to any other data. A table can be in 3NF but not in BCNF. This occurs when a non-key attribute is a determinant of a key attribute. This table is in 3NF. A and B are the keys and C and D depend on both A and B. There are no transitive dependencies existing between the non-key attributes C and D. The same table is not in BCNF because dependency exists between C and B. In other words, if we know the value of C, we can determine the value of B. Consider the student table of the university database. If we know the student number (SNUM) and teacher code (T-code), we know the offering, that is class where the student is in. You can also know the review date for that student and teacher. Student progress is reviewed from the date for the class by the teacher and student. The dependencies are SNUM, T-code, offering, review date, or SNUM and T-code implies offering, SNUM and T-code implies review date, which means that the table is in third normal form. The table is not in BCNF, as if we know the offering number, we know who the teacher is. Each offering can only have one teacher. Offering T-code or offering implies T-code. A non-key attribute is a determinant. If we look at the table, we can see a combination of T-code and offering is repeated several times. Example, FIT 104 and 01764. This situation is resolved by following the steps below to convert into BCNF. SNUM, offering, T-code, review date, or SNUM and offering implies T-code. SNUM and offering implies review date. The determinant offering becomes part of the key and the dependent attribute T-code becomes a non-key attribute. SNUM offering T-code, review date, or SNUM and offering implies T-code, SNUM and offering implies review date, offering T-code, or offering implies T-code. There are problems with the structure as T-code is now dependent only on the part of the key. This violates the rules for 2NF, so the table needs to be divided with a partial dependency, becoming a new table. The original table is divided into two new tables. Each is in 3NF and in BCNF. Student offering review table, offering teacher table.
Higher normal form. These three normal forms are considered as higher normal forms. multi-valued dependency. Fourth normal form. Fifth normal form. Multi-valued dependencies. To deal with the problem of BCNF, multi-valued dependency MVD was introduced. A multi-valued dependency MDV is a functional dependency where dependency may be to a set and not just a single value. Here, A1, A2 and so on up to AN is dependent to B1, B2 and so on up to Bm is an MVD, a multi-value dependency where A and B are attributes for a relation R if whenever two tuples S and T in R agree on A1, A2 and so on up to AN, there must exist a tuple U in R that agrees with S and T on A1, A2 and so on up to AN, agrees with S on B1, B2 and so on up to Bm, agrees with it on all other attributes. From the above table, a dealer can sell several makes of vehicles, but for each make the dealer deals, the dealer must sell all products in the line. So, Jones, having chosen to work with Toyota, must sell both its trucks and its cars. However, we are imagining that VW does not produce trucks, so VW only requires Jones to sell their cars.
Fourth normal form. Relation R with MVDs is in 4NF if for each non-trivial A to B, A is a key. BCNF A to B, A is a key. For NF decomposition algorithm, input relation R plus FDS for R, MVDS for R. Output decomposition of R into 4NF relations with lossless join. Compute keys for R. Repeat until all relations are in 4NF. Pick any R' with non-trivial A to B that violates 4NF. Decompose R' into R1 of AB and fifth normal form. A relation R is in 5NF if all R joint dependencies at least one of the following holds. R1, R2 and up to Rn is in trivial joint dependency. Every Ri is a candidate key for R. Definition: let R is equal to R1, R2 and so on up to Rp is a set of relation schemes over U. A relation R of U satisfies the joint dependency JD into R1, R2 and so on up to Rp if R decomposes losslessly onto R1, R2 and so on up to Rp, that is, R is equal to pi R1 of R join pi R2 of R join and so on up to join pi Rp of R. We also write joint dependency R1, R2 and so on up to Rp as joint dependency R. The table is said to be in the 5NF if it is in 4NF and every joint dependency in it is implied by the candidate keys. Sometimes it is impossible to break the table into two tables. That is when you can use the rules of 5NF to normalize. Generally, a table in 4th NF is always in 5th NF, but sometimes real-world constraint will cause the relation to be not comply with 5th NF. psychiatrist to insurer to condition. Process of normalizing. These steps demonstrate the process of normalizing a fictitious student table. First normal form. No repeating groups. Tables should have only 2 dimensions. Since one student has several classes, these classes should be listed in a separate table. Fields Class 1, Class 2 and Class 3 in the above records are indications of design trouble. Spreadsheets often use the 3rd dimension, but tables should not. Another way to look at this problem is with a one-to-many relationship. Do not put the one side and the many side in the same table. Second normal form. Eliminate redundant data. Instead, create another table in first normal form by eliminating the repeating groups, that is class, as shown below. The multiple class values for each student value in the above table. Class is not functionally dependent on student, that is a primary key. So this relationship is not in second normal form. The following 2 tables demonstrate second normal form. Third normal form. Eliminate data not dependent on key. Advisor room. The advisor's office number is functionally dependent on the advisor attribute. The solution is to move that attribute from students table to the faculty table as shown below. Student table and faculty. Summary. In this class, we have learnt about what is normalization, normal forms and its types, Boyce code normal form with examples, what all are higher normal forms.